Welcome to the video on ratios and proportions. We're going to remind ourselves what it looks like to have a proportional relationship. So there's two ways that we may see this. We may look at a graph. So when we have graphed relationships like we do on the left side here, we're talking about looking at an actual graph. And we know it's proportional if we have two things when we look at graphs. And that's if the line is straight and the line goes through the origin. We must have both of those things in order to be proportional. Now, when we look at a table, which is the second way that we might be looking at these, the table relationship is proportional if the ratios are the same. Okay, so let's look at number one. Okay, so for number one, we're looking at this table of information where we have the calories that are burned. And we have number of minutes, which we can see is also labeled on the x-axis of my graph. And then the y is the number of calories. That's on the y-axis on this graph. And we have this data. So the first thing we want to do when we're given x's and y's is we want to make it look like points so that we can actually plot the information, and then I can decide if it's proportional by looking at the graph. That's what this question is asking me to do, because they're giving me an x and a y, and I have this graph that's empty over here. That's showing me I need to graph this information so that I can see if it's proportional or not. So to start off, we need to put all these points, the x and the y values, into a coordinate so I can actually graph it. So this is an x value of 0, a y value of 0. So I write that with the parentheses around it and then 0, comma 0. Now remember, that helps us to know that it's a point. When I see it with those parentheses around it, I know that it's a point. So 1 is my x in the next one, and 6 is my y, so the point will be written as 1, comma 6. And then we continue with this pattern. So the 2 is the x here, with a 15 as a y, so that's written as 2, comma 15. And then the last one is 3 as the x value, and 30 is the output. So 3 is your x input, y is 30, your output. So I'm going to write that as 3, comma 30. Okay, so now I need to plot these points on the graph. So you're going to want to make sure that you're looking for the points. So the first one is 0, 0. So I'm going to put that right on the 0, 0 origin there. And then I'm going to plot my next point, which is an x value of 1 and a y value of 6. And then an x value of 2, and the y value is at 15. So I'm going over to an x value of 2, that's to the right 2, and then up to 15. And then the last one is 3, so over to 3 on the x-axis, and up to 30 on the y-axis. Okay, so now I plotted the data that I was given. Now I'm going to try to connect it with a straight line. So if you have your ruler and you want to just take your ruler and line up with that first point and try to connect to the other ones. So when I try to use, if you can picture this as just your straight edge, don't draw that line yet, just kind of picture it. What happens is I don't go through the data, so I can't keep my line as one straight line. It just has to start and end at the first 2 points, and then I'm going to have to move my ruler to be able to connect the next 2 points. So the next 2 will be a little different. The slope here is a little different than what I had in the first point when I connected them, and then that's going to also change when I go up to connect to that third point. So when I just try to use my straight edge, what I notice is that I can't connect with a straight line. So my follow-up questions here start off with, does it go through the origin? Well, my answer there is yes, it did start by going through the origin. But my answer to the next part, is it a straight line, is no. So if I use my notes from above, I know that the line needs to be straight and needs to go through the origin in order to be proportional. So my conclusion that I can draw here is the relationship is not proportional. Okay, let's try looking at the next one. Now, number 2 is just kind of reminding us of how we find this unit price. And that's talking about how much something is for just one. So for this example, we have Harold who bought 5 apples, and the cost is $1.30. we're wondering what the unit price is. So the unit price is how much would it cost for just one apple. So to do this, remember this is where we came up with that fraction where we talked about how money is usually in the top of our fraction. So in this case, the money is the $1.30. So based on the question then, the $1.30 goes in the numerator. And we want to find out the unit price. The unit price is going to be how much it costs per apple. So if I'm paying $1.30 for 5 apples, if I do $1.30 divided by 5, I'll find out the cost per apple. So when we do this, now we can use our calculator. 1.30 divided by the 5 apples gives me 0.26. Now that's not done yet because we have this label that was in the question. This wasn't just numbers, this was a cost per apple. So my answer needs a label. So the 0.26 means it's 26 cents per apple. And that's my answer for this question. They asked us to find the unit price. The unit price is how much it costs per apple. So that's why we put that numerator as the dollar amount. So our unit price is usually how much per whatever the unit may be. All right, let's try another one. All right, so for number 3, this one, we're given a table this time. So now we're going to talk back to what we wrote at the top of our notes with the table. To find out if it's proportional, we need to find what the K would be. So remember, K is the constant of proportionality, and we find it by dividing the y by the y divided by the x. So in order to do this, I need to know that my tables, and usually they're written in the form of an x and a y, but x usually refers to some kind of time. So I know that my first column here is my x, and the temperature is going to be my y. So we need to find the constant of proportionality. Remember, if it's proportional, it'll mean when I do the division for all of these, the answers should all be the same. So to start off, we need to do all of these. So I'm going to look at each of them, and I'm going to divide the y. So in the first one, x is 9, 60 is your y. You could write this out as a point if you wanted to, but this is my x and this is my y. So to find that constant of proportionality, I'm going to replace the k. I'm going to write k equals, and then I'm going to replace the y with the 60 and the x with the 9. So then when we put this in as a fraction, because if we try to divide 60 divided by 9, it doesn't come out nice. So when I do this division, put it in as a fraction instead, my calculator will tell me that 60 divided by 9 is equivalent to 20/3. So now I'm going to do the same thing with the next point to see if it's proportional. So the next one is a 62 and a 10. So to do this, I'm going to try the same thing. So I'm going to start with the k equals, but the y is now going to be a 62 and the x is going to be 10. So when we do, again, as a fraction, 62 tenths, in our calculator, that should reduce to show us that the equivalent fraction is 31 fifths. So now when I look at these two, we should be able to decide if it's proportional right now. What do you think? Based on these two fractions, is this relationship proportional? Well, no, the answer is no, because right now, these two are not the same. Just to be sure I didn't make a mistake, I like to continue doing the other ones as well. So now I'm going to set up the next one, which would be a 64 divided by 11, y over x. And when we try putting that fraction in, it does not reduce, so that's as low as that fraction can go. And then the last one would be a 66 divided by 12. And that 66 divided by 12, again, putting that in as a fraction, will reduce to 11 halves. So when I look, I know now, looking at all of these k's, this is not proportional, because if it was, all of my k's would be the same. So since it's not, I don't need to say what the meaning of k is. So this relationship is not proportional. So that's number 3. The relationship is not proportional. And then make sure that you put a circle around that so we know that is our answer. Okay, number 4 is telling us that Value Mart is advertising a back-to-school sale on pencils. A pack of 30 sells for $7.50, and then we also have a pack of 12 of the same brand that costs $3.48. Which is the better buy? So what are we looking for when we're asking for the better buy? What would that mean? How do I know which one's better? Well, to find out the better price per pencil, I like to look at the 2 options and try to determine which one is a better per pencil price. So I'm going to look at the 30 pack first. And similar to what we did above, we're going to need to put money in the top. So in this case, to remind myself of that, I'm just going to put the $ with the fraction above it again up in the top to remind me that money goes in the top. And I'm going to look at this question. So the money for the 30 pack is $7.50. So I'm going to start by putting $7.50 in the top of a fraction. So then I have my money in the top, and I'm going to divide by the 30 pencils. And when I do the division, this will tell me the cost per pencil. So when we do the division, 7.50 divided by 30, we get 0.25. But in the context of the question, that doesn't really help me understand what's going on. So what that means is the cost is 25 cents per pencil. So we write that out with that label like we had in the fraction. So I had the money per, that's what the fraction line is for, pencil. So this is the amount per pencil. All right, now let's look at the 12 pack. I'm still using that same idea of the money in the top. So I'm still going back to this fraction idea. So the money for the 12 pack is $3.48. So now I'm going to put the $3.48 in the top, and that's the cost for 12 pencils. So I'll put that in the denominator. So $3.48 per 12 pencils. So now we'll do our division again. So when I do that division, 3.48 divided by 12, I get 0.29. Now again, that doesn't really mean much. In the context of the problem, what that tells me is that is my cost per pencil. So what this 0.29 means is 29 cents per pencil. So my question now is, which is the better buy? Well, the better buy is the one that's cheaper per pencil, so the 30 pack is the better buy. So the answer to the actual question is that the 30 pack is the better buy. That's why you see that at the bottom, and I put a circle around it so that I know that is the better option. All right, let's look at the last one. Okay, so for number 5 at the bottom here, we have the graph. It shows the amount of chocolate consumed by people. And they're telling us to use k equals y over x to find the constant of proportionality of the graph, and then explain what it means. So when I look for k equals y over x, I need to find a point. So it doesn't matter which of these points that you use, but we do need to remind ourselves that which of the axes is the x? Is that the one that goes across the bottom, or is that the one that goes along the top on the left-hand side in this graph? So which one is x? Is it the people, or is it the chocolates? Well, it's the people. So on that, I'm going to put an x. And that just reminds me that my x's are on the bottom there, and then a y along the other axes. So now when they're asking me to find k equals y over x, and I highlighted that in my question, I can use any one of these points to figure that out. So off to the side, I'm going to write the k equals, and I just use the first point. You could use any of them. I used the first good point here, right here. So I used 6 as my y and a 3 as my x. If you wanted to write out this point to remind yourself what that looks like, it's 3, 6. Why don't you do that for me in the bottom here below people? Can you write the point? So we're going to write a parenthesis, 3, 6, and close your parenthesis to remind ourselves that that is what this point represents. That's where we got this 6 over 3. Now we can do that in our calculator. 6 divided by 3, you can put it in as a fraction or do the division. Either way, you'll get 2. Question is, what does that 2 mean? That 2 is telling me, remember that it was y over x, so that's the y value, which we labeled on the side, that's the chocolates per, and on the x we have person or people. So this means that the chocolate is consumed at a rate of 2 chocolates per person. So that's kind of my big idea here, that it's whatever the y value is, the number, and if it was a fraction, that would be the number that's in the top, per, and then what's in the denominator, which is your x, would be the x label from the graph. So I just wrote per person since it was down to 1 person. If it was a bigger number, we might instead use the label people. Okay, so hopefully this helps you to complete the next page, which is the flip-flops page, and we'll go over it more in class. Have a good day.